of integration which we can use in the topic of polar coordinates. Basically, integration is not directly part of AS level for the mathematics, but it is a tool which is applied in polar coordinates along with differentiation and integration. Sorry, along with differentiation and trigonometry. So let's just start with some of the properties. Okay, as the first is, if we integrate sine theta, it become negative cos theta. Okay, and similarly, if we integrate sine 2 theta, so it will become negative cos 2 theta divided by 2. Okay, now third is, integrate cos theta becomes sine theta, and for cos 2 theta it will become sine 2 theta upon 2. Then if we move ahead, there's some more properties, like fifth is for integration of sec square theta is tan theta, and for cosec square theta is negative cot theta, which I am going to write here. Okay, so let's move ahead. For seventh property, here is cosec theta and cot theta, it become negative cosec theta. Let me check one thing. Okay, so 8 will be cosec theta, and cot theta was there, will become negative cosec theta, and on the other hand sec theta and tan theta. One second. Yes, sec theta will be sec theta. Okay, and on ninth, yeah, on ninth I am going to discuss a formula. We can say as it is formula or anything, is that we can also say it by part method. Yes, so it is like this. We have this, okay, and it is equal to, when we integrate it, it becomes uv plus integral u differentiation v. So I want to apply here, okay, to identify the integral of tan inverse theta. Okay, to identify the integration of tan inverse theta, we will apply by parts. How we will apply? So let's have a look at this. Basically, I am working with purple color. Okay, so it is same as this integral tan inverse theta multiply by 1 d theta. Okay, the inverse function will be u and this will be v. Okay, so we have u as, and sorry, that is not v, that is v differentiation of v. U is tan inverse theta, and if we differentiate it, it will become 1 upon 1 plus theta square. Okay, and we have v prime, it is 1, so v will be theta. Okay, so let's do ahead. uv, okay, first we will write uv here. U is tan inverse theta, it is getting multiplied with theta plus integral v prime. Okay, this is v, differentiation of u, 1 upon 1 plus theta square multiply by v. Okay, this is theta, so we can write it as theta upon 1 plus theta square d theta. So it become tan inverse theta, let's make a space here, theta tan inverse theta and plus integral theta upon 1 plus theta square. Now before completing this, I want to introduce one more property. It's basically a shortcut. Okay, so I want to introduce this as 11th one, and we will use this in 10th. Okay, integral f prime x upon f of x is equal to ln modulus f of x. So it is like this, that the function which is in denominator, the numerator will be its differentiation. Okay, then we can write its integral as ln f of x. Okay, if we look here, let's come back with purple. If we look at this, its f prime x should be 2 theta, but the problem is there is not 2 theta, so we can make it 2 theta by theta tan inverse theta plus integral, what we have to make it 2 theta and 1 plus theta square. To balance this, we will divide 1 upon 2 here, multiply 1 upon 2 here. Okay, so if you look at this, that this 2 cancel, but we don't want it. Okay, by using shortcut we can write theta tan inverse theta plus 1 upon 2. Now we can write it as ln 1 plus theta square. So here we derive this. integration for tan inverse theta. Okay, now I want to share just some more properties and then I will end this video. Okay, so now I'm moving for 12th property. Before that, just have a look on this. We had given that u and v prime, and then we find u and differentiation of u, v and differentiation of v. Okay, then we just use by parts and we just try to simplify things. We use shortcut, which is our rule 11, and then we got easily our answer. Okay, so let's move ahead for 12th one. 12th is like this. If we have something a upon b, one nut, a upon b, and there is let's write it 7 minus theta. I'm just giving an example. So sorry, integral of, we are doing is integral. Okay, so its integral will be a upon b will remain same, and there will be ln 7 minus theta. Okay, because this is a constant here, that's why. Now 13, just some more properties. As 13 is also easier one. 1 plus u square is equal to tan inverse u. Okay, then 14th is 1 upon a square plus u square will be reciprocal of a tan inverse x divided by a. Now 15th is e power 2 theta is equal to e power 2 theta divided by 2. And now we are left with the last one. 16th is sec 2 theta is equal to ln modulus sec 2 theta plus tan 2 theta divided by 2. So just have a look on all the properties and then we will end the video. The sine theta will become negative cos theta, and the sine 2 theta will become negative cos 2 theta upon 2. The cos theta will become sine theta, and the cos 2 theta will become negative cos sine 2 theta upon 2. Sorry, positive sine 2 theta upon 2. Then there is a sec square theta which will become tan theta, and the cosec square theta which will become negative cot theta. Then cosec theta multiplied by cot theta will become negative cosec theta, and the sec theta tan theta will become sec theta. Then we use by parts. Okay, and we got the integral of tan inverse theta as theta tan inverse theta plus 1 upon 2 ln modulus 1 plus theta square. Then we learn about a shortcut, and we had also used that shortcut. Okay, then we had look over the integral of a upon b 7 minus theta, as a upon b will remain as it is, and the ln 7 minus theta. Then 1 upon u square will be tan inverse u, and 1 upon a square plus u square is equal to 1 upon a tan inverse x upon a. I think so. There will be not x, there will be u because we are using u. Yeah. And the integral of, okay, they all are integral. Integral of e to theta will be e to theta upon 2, and integral of sec 2 theta will be ln modulus sec 2 theta plus tan 2 theta modulus of divide by 2. So thank you for watching this video.